If you've been hearing about MCP or Model Context Protocol but don't really understand what it is, then this video is for you. Today, we'll build a complete MCP server in Java using Spring Boot and Spring AI. Instead of building a complicated project, we'll start with a simple calculator so you can understand the complete workflow. By the end of this video, you'll have your own MCP server running and you'll test it using the official MCP Inspector. Before we start coding, let's quickly understand what MCP actually is. MCP stands for Model Context Protocol. Think of it as a standard way for AI applications like Claude Desktop, ChatGPT, Cursor, or VS Code to communicate with your application. Instead of the AI directly accessing your database or business logic, it talks to an MCP server. The MCP server exposes tools, and the AI can call those tools whenever it needs them. In today's video, we'll expose calculator operations as MCP tools. Before we start building the MCP server, let's first understand the prerequisites. We'll be using Spring Boot 4.1, which requires Java 21, so make sure you have JDK 21 installed on your machine. We'll also need Node.js because we'll use the official MCP Inspector to test our MCP server. I'm using Node.js version 24.18.0, but any recent LTS version should work. Let's create a new Spring Boot project. I'll use Spring Initializer inside VS Code. We'll use Maven and Spring Boot 4.1.0. Our project name will be Java MCP Calculator. We'll use Java 21. Next, let's add the Spring Web dependency. Import the project and open it in VS Code. In pom.xml, we added extra dependencies specifically for the MCP project. This Spring AI bomb tells Maven which version of all Spring AI libraries to use. Next, we have added Spring AI Starter MCP Server Web MVC. It automatically provides MCP Server, our MCP endpoint, tool registration, Streamable HTTP transport, MCP protocol implementation. Without this dependency, your application is just a normal Spring Boot application. And this Spring Boot Starter is added only for debugging purpose. It allowed us to open actuator mappings. Now comes the interesting part. Instead of creating REST APIs, I have created an MCP tool. I have created a class named Calculator Tool. Inside this class, we'll implement 4 operations: add, subtract, multiply, divide. Each method is annotated using @tool. The description is important because AI models use it to understand what each tool does. Simply creating a tool isn't enough. We also need to register these methods with Spring AI. For that, we have created a configuration class named MCP config. Here, we have created a tool callback provider bean. This tells Spring AI to expose all the methods inside our calculator tool as MCP tools. Now let's configure our MCP server. Inside application.yml, we have define application name, MCP server name, version, Streamable HTTP protocol. Let's run the application. We will use this Spring Boot run command. But before that, you need to run clean install command. I have already done that, so I will directly run Spring Boot run. If everything is configured correctly, Spring Boot starts successfully. As you can see, application has started. Now I'll open a new terminal while keeping the Spring Boot application running in the first terminal. In the second terminal, we'll launch the official MCP Inspector by running npx model context protocol /inspector. This command downloads and starts the MCP Inspector, then automatically opens it in your default web browser. Think of MCP Inspector as Postman for MCP. It allows us to connect to our MCP server. This is the MCP Inspector interface. Since our application is using Streamable HTTP, I'll select Streamable HTTP and enter the URL with /MCP. And then click Connect. Great! Our MCP server is now connected successfully. The inspector automatically communicates with our server and discovers all the tools that we've exposed. If I open the Tools section and click List Tools, we can see all 4 calculator tools that we created. Add, subtract, divide, multiply. We can invoke any of these tools directly from the inspector without writing a single REST controller or creating any custom API endpoints. Before we conclude, let's verify something interesting. We never created any controller or endpoint named /MCP, yet our application is exposing MCP endpoints automatically. That's because the Spring AI MCP Starter generates these endpoints for us. To verify this, open the /actuator/mapping URL. Here, you can see the endpoints automatically created by Spring AI. These are the endpoints used by MCP clients to communicate with our server. Let's get back to our MCP Inspector. Let's execute the Add tool. I'll enter 2 numbers and click Run Tool. As you can see, the result is returned immediately from our Spring Boot application. At this point, our MCP server is fully functional. However, notice that we're manually invoking the tools using MCP Inspector. In the next video, we'll replace MCP Inspector with an actual AI model. We'll connect OpenAI to this MCP server using Spring AI, and instead of manually clicking the Add tool, we'll simply type Add 25 and 30. The AI will automatically discover the available calculator tools, choose the appropriate one, execute it, and generate the final response for us. That's where you'll truly experience the power of MCP. If you have any doubts, feel free to leave them in the comments below. Thanks.